Good afternoon, children. In today's class, we are going to study the next concept is what are the heating effect of current. So we know that electricity because of the current, we can produce the magnetic effect as well as the heating effect. Now we will study what is the heating effect of electric current. In the next chapter, we will study what is the magnetic effect of electric current. So let us comes to here. We know that whenever the electricity passes, it will definitely will produce some amount of heat energy. So means Fx produced by electric current. Understand? So if you take basically what are the effects which can produced by the electricity is three important effects. One is heating effect, next one is magnetic effect, and the next one is chemical effect. So even in lower classes you have studied what is the chemical effects of electric current. I think in class 8th science you have studied chemical effects of electric current. Like that now in this class 10 you will study what is the heating effect of electric current and like as well as magnetic effect of electric current. So now in this chapter we'll discuss the heating effect of electric current. The magnetic effect of electric current will be discussed in the next chapter. Understanding? And like if it comes to the chemical effect, you have already studied the chemical effect, but the formulas, how it is happening more in detail you will study in the higher classes. So let us come to here today's session. We are going to study heating effect of current. So what is the meaning of this means? When any kind of conductor, if you have taken, when an electric current is passed through a very high resistance wire. Understand? Some conductor means or some wire I have taken, which is having a very high resistance, means the flow of electricity is very slow. So the resistance wire become very hot and start producing the heat energy or else heat. So that is only called the heating effect of current. Are you understanding? When an electric current is passed through a high resistance wire, like suppose for example if we take the best example of high resistance wire is called as nichrome wire, then the resistance wire, understanding, the resistance wire becomes very hot and produces heat. So this heat is called the heating effect of current. So the heating effect of current is obtained by the transformation of which energy from which energy? From electrical energy to, understand, electrical energy to heat energy. Remember, here the transformation of electrical energy into heat energy will give you the heat effect. So just like a mechanical energy used to overcome the friction. Suppose if you want to move the bike or something, you have to apply some more amount of mechanical energy needs to overcome the friction, which is converting into heat. Understand? Which will converting into heat. In the same way, the electrical energy is converting into the heat energy when an electric current flows through a resistance wire. Understanding? So here the role of resistance, what is the meaning of, what is the importance of here resistance? The role of resistance in electrical circuit is similar to the role of friction. Understand? Role of friction in, understanding, mechanics. So wherever you are using, whenever you suppose if you want to slide my hand here, then you have to apply some amount of mechanical energy which needs to overcross this frictional force, because frictional force always is acting opposite to the motion of the body. So here, because of this friction, rubbing action between the mechanical energy and the friction, some heat energy will be produced. Like same way here in electricity, the resistance of the wire is, understanding, similar to the role of friction in mechanics or understanding, like in the sense of like mechanics means in physics. Okay, mechanics is one of the part of mission understanding, like in mechanical engineering and all you will study about the mission, how the force is acting, in what angle, understanding how much is acting, what is the effect, like that we have studied. So this is a friction in mechanics. Remember, the resistance is similar to the friction. That's all you can remember. So now we will derive the formula for calculating heat produced when an electric current flows through this particular kind of resistance wire. Understand? So let us take, since we know that every resistor is a conductor and every conductor is having some resistance. So let us take, since a conductor says a resistance wire offers resistance to the flow of current. So work must be done by the current continuously to keep itself flowing. So somebody is opposing this flow of current, then but it wants to move forward. So definitely some kind of work definitely will be done by this current continuously to keep move forward itself in flowing. So now we will calculate the work done by the current when it flows through a resistance R for time t. Understand? For time period t in a resistance R, when the current will flow, how much work is done by it, we will see. So now we know that when an electric charge Q moves against a potential difference of V, then the amount of work done, we have already studied, when Q charge is flows, understanding, across a potential difference of V, then we know that work done W is equals to Q into V. So this is the one formula which we know to us. So let us keep that is the one. So now from the definition of current, we know that I is equals to what? I is equals to Q by T. So let us take, this is the equation number 2. So from this, or else you can take from this, we is to get one more equation, that is Q is equals to I into T. So let us take, this is the equation number 2. Understand? So now, and also we know that from the Ohm's law, understanding, from Ohm's law, also we know that V by I, which is equals to what? R. Is it correct or not? Yes. So from this I can take V is equals to I into R. Understand? So why we are taking these two, sir? Because we know that work done, which is equals to what? Q into V. But here who is doing the work? Current is doing the work to move forward in a given resistor for a particular time period. So that we are trying to bring this work done in the form of current and time. Understanding? Current and time. So let us see. Let us substitute these values. Understanding? So let us take, this is the equation number. Understanding? It is the equation number 3. So now substitute equation number 2 and 3 in the equation number 1. Understand? Then let us see what we is to get. So we know that substitute 2 and 3 in 1, then we is to get W work done is equals to, understanding, W work done is equals to, so two things we have to substitute. One is what? Q is equals to I into T. Next one, V is equals to I into R. So let us substitute in the place of Q. If I will substitute, which will become I into T, understand, into, in place of V I can substitute I into R. Understand? So now you know that W work done, W is equals to, here 2 i's is there, so I into I square. Understanding? R is there, R into T. That's all. So this is called as, understanding, assuming that here the work done in the sense of what? Electrical work done. Electrical work done, W is equals to, what is going to happen? I square into R into T. Understand? So here all the electrical energy consumed is converting into which energy? The work done by this electrical energy is completely converting into heat energy. Understand? It is completely converting into heat energy, in the sense of, we can say, the heat produced in the place of work done. Understanding? The work done, the amount of work done by the electrical energy, which is equals to what? Heat energy produced by the wire or else the resistance. So that in the place of work done, I can replace with what? H, which is equals to I square into R into T. So this is the formula. Understanding? But we know that heat energy, what is the unit of heat energy? Which is equals to joules. That's all. So this formula gives us the heat produced in joules when a current of I amperes, understanding, flows in a wire of resistance R, which is the wire which is having a resistance R in the sense of R ohms. Understanding, ohms is the unit of resistance for time t seconds. Then the heat energy produced by the body, which is equals to work done by the electrical energy. So this equation is only known as, remember, Joule's law of heating, very most important. Joule's law of heating. Understand? This is only known as the Joule's law of heating. So according to this Joule's law of heating, what it will say? The heating, understanding, the heating given by the formula H is equals to I square into R into T. Understanding? From this we can say that the heat produced in a wire is completely directly proportional to, understand, square of current. H is directly proportional to square of current. H is directly proportional to resistance of the wire, and H is directly proportional to time t for which the current is passed. Understand? So since the heat produced directly proportional to the square of the current, you have to remember, then if we'll double the current, what is going to happen? If we'll double this current 2 times, then the heat produced will become 4 times, because it is square. 4 times it is increases. Understand? If the current will become double, then the heat energy produced by it is increases 4 times, because suppose see, if we take 1 ampere, then the heat produced by is 1 square, which is equals to 2. Now suppose the current will become double, 2 square, in the sense of what? 4. So if the current will become double, then the heat produced will become 4 times. Understanding? Suppose if the current will become half, the current, understanding, then the heat generated will become 1/4. These are the things very important in the case of assertion and reason questions. Understand? Like the second one, since the heat produced in a wire is directly proportional to the resistance, so we can say that H is directly proportional to R, in the sense of, if R will increases 1 times, means if R will increases double, if R will become double, then the heat energy produced also will become double. That's it. If resistance will become half, then the heat energy also will become half. Okay, so a given current will produce more in a high resistance wire than in a low resistance wire. If you keep the current is constant, understand, then if you pass in the 2 different kind of wires, which is having a low resistance, which is having a high resistance, then here the heat energy is more, and here the heat energy is less. So if resistance of the wire is more, then the heat energy produced by his wire is also more, because even though the constant current. That is you have to remember. A given current will produce more heat in a high resistance wire than in a low resistance wire. Okay. So this is, so we know that when 2 similar resistance, understanding, wires are connected in series, then their combined resistance will get what? Their resistance will become double. But when they are connected in parallel, their resistance, the combined resistance will become half. That is also you have to remember. So same 2 equal resistors, when they are connected in series, resistance will become double. If they are connected in parallel, then the resistance will become half, or else half we can say. Okay, so from this we can say that a given current will produce more heat per unit time if the 2 resistances are connected in series connection. Understanding? Series connection than when they are connected in parallel. These are the informations which is too useful for reason assertion, most important. Okay, so like a given current will produce more heat energy in a high resistance wire than in a low resistance wire. Like that, a same kind of resistance, if you will connect 2 resistors are connected in series connection, they will produce the heat produced will become double, in the sense of the heat produced per unit time if the 2 resistors are connected in series, understanding, is more compared to the when they are connected in the parallel. Understand? Like that. If it comes to the next one, understand one more factor, that is, since the heat energy produced in a wire is directly proportional to time also, time for which the current will flows. So I can write it, H is directly proportional to T. So if the current is passed through a wire for double the time will become double, then the heat energy produced also will become double, because both are directly proportional to each other. If the time will become half, then the heat energy produced is also become half. Understand? So this is all about the factors which will influence the heat energy produced in a given resistance. Now let us see. Understanding. So this formula H is equals to, we can use I square into R into T. We will use this formula solve to some problems based on heating effect of current. Understand? So H is equals to I square into R into 2. For calculating heat produced can be used only if the current I, R and time understanding are known to us. In some cases, suppose if you don't know this understanding, they give us the power directly, only power and time they will give. So in this case, the heat energy to be calculated by using the formula called as E is equals to P into T. So here E is indicating what? Heat energy produced by the understanding resistance. But here in this case, this formula we have to use in the case of power understanding and time when they have given. That is the thing you have to remember. So here you should be note that all the appliances which run on electricity do not convert all the electrical energy into heat energy. Only the electrical heating appliances convert most of the electrical energy into heat energy. But every appliances will convert some heat energy. So only the heating appliances convert most of the electrical energy into heat energy. Suppose if we'll take, for example, when electric current is passed through an electric appliances such as fan, you can take, then most of the electrical energy is used what as using in running the fan, in the sense of turning the fan, mechanical energy. Only very small amount of electrical energy is converting into heat energy by a fan. Remaining all energy, electrical energy is converting into mechanical energy to rotate the fan. Understand? So due to this, we can say that electric fan becomes slightly warm when runs continuously for a long time. Understand? Like that, when electric current is passed through an electric heating appliances, your home is having a geyser, or else you are having a water heater, some kind of thing, you can see that, or else some kind of a toaster or something, you can see that. So then, when the electric current is passed through this electric heating appliance, such as an electric heater, electric kettle, hair dryer, understanding. Next, like a geyser, or also we can call it as immersion rod. Immersion rod or geyser means if you directly immerse in water, immersion rod or else geyser, the most of the electrical energy is converting into heat energy. Understand? So all the electrical heating appliances have their inside, they're having some heating element called as heating coil. Understand? So there, what is their duty? They will convert most of the electrical energy into heat energy. So this is heating coil, or else we used to call it as heating element. Understand? So which is made up of how? Which is made up of high resistance wire. High resistance wire. The wire which is having very high resistance called as, like example, nichrome wire. Understand? So many we are having, but the best one cost effective is nichrome wire, which helps in converting most of the electrical energy into heat energy. That is the main purpose. Understand? So this is about the heating effect of electric current and what are the formulas for calculating the heat energy produced by the understanding. Heat appliances or normal appliances also, but normal electrical appliances will produce only less amount of heat energy, but heat appliances will be producing maximum amount of electrical energy into heat energy. Okay, so this is all about the heating effect of electric current. Understand? Now let us see what is the applications of this heating effect of electric current. So somewhere we want to convert this electrical energy into heat energy. So let us see where we need to use this electrical energy into heat energy. For example, if we'll take, we are having so many important applications of heating effect of electrical current or energy. So let us come to here. First one, the heating effect of current is utilized in the working of electrical heating appliances, such as if you take ironing, electric kettle, water heater, electric toaster, bread toaster, you know that, like electric oven you are using that making puffs and something like a, what it is in a parota or something, you guys know that, what we can say, pizza, burger and all used to make with electric oven, like that, room heaters, water heaters or geysers, everything. All these heating appliances contains coil of high resistance wire. Applications, only we used to call it as applications of Understand applications of heating effect of current. So these all the kind of appliances, heating appliances contains a coil of high resistance wire which is made up of nichrome wire. So when these appliances are connected to the power supply by how? By insulated copper wires, then the large amount of heat is produced in these heating coils because of their they have very high resistance. So copper wire will send the most of the electrical energy to this coil. So there, this coil will convert because of high resistance. Most of the electrical energy is converting into heat energy. Understand? But a negligible heat is produced in the connecting wires of copper also. Understanding? Because copper is also having a very low resistance. So every appliance, every conductor is having some resistance. So some energy will be produced, but will be negligible. Understanding? But for example, if we'll take the heating element, like that coil of an electric heater, if we'll take, which is made up of nichrome wire, once it will pass the electrical energy continuously, after a few minutes, particular time period, it will glows because it becomes red hot due to the large amount of understanding heat produced on passing current. Because why? Because of its high resistance. Because of its high resistance. Understand? But if we take the cord or connecting cable of the electric heater, means which will supplying the electric energy to that coil, that is only we used to call it as cord. Understand? Cord or connecting wire. Okay, connecting cable. Cord or connecting cable. Understanding? And passing the electric heater made up of copper. Understand? Does not glow because they are having a very negligible heat is produced in it by passing current. So because of its low resistance, this cord is having very low resistance, so it will never turns into red color. So because you remember that is why. So the temperature of this heating element or this coil, which is made up of inside the heating appliances of an electrical heating device, when it is becomes red hot, it glows is about almost 900 degrees Celsius. You just imagine. So it is shining in the sense of it is used to produce the temperature of around 900 degrees Celsius. That much high temperature will be produced. Understand? Even it will take very less time itself. That's all. Even we can take electric iron also. Electric iron also, bottom part it is made up of some metal, correct? But inside, and suppose let me take, if you imagine the iron coil bottom will be like this. Is it correct or not? Yes. So inside we're having some kind of a connector, copper wires connectors will be there. But here we're having a nichrome wire, like this is called as coil. So which is present like this. Like this way it is used to present inside, so it will be producing the most of the heat energy. So here the electrical energy will come there and will produces most of the heat. Electrical energy is converting into heat energy, again it will be like this. Understand? So here this is what nichrome coil, a coil or nichrome coil. So basically it is made up of nichrome. Okay, so this is the first one. Like that. Second one, the heating effect of electric current is utilized in electric bulbs or else electric lamps for producing light. So if there is no heat effect, there is no light will be produced. Understanding? From a normal bulbs, you can see that. Understanding? Now we are not using, now we are using this kind of bulbs. So this kind of bulbs you can see olden days and all. Nowadays it is shifted to fluorescent bulbs or LED bulb. So these bulbs is having a filament inside. So this filament is also made up of what? Tungsten. You guys know it. So these kind of bulbs, understand? So when the electric current passes through this very thin and high resistance tungsten filament, which is present inside here, understanding of an electric bulb, the filament becomes white hot and start emptying the light because of its resistance only. So here the same current flowing through the tungsten filament of an electric bulb produces very heat, high, enormous heat we can call it as. Enormous heat, but almost negligible heat is produced in the connecting wires of copper. So because of this fact, the fine tungsten, very thin it is, correct or not? This filament has very high resistance. Understanding? Whereas the connecting wires which is bringing the current to it is having a very low resistance. So this tungsten metal, which is used for making this filament of electric bulb, because it is having a very high melting point, it can resist even a very high temperature. So the temperature of this tungsten, which is equals to 3380 degrees Celsius. Because of that, we are using it as a filament. Why we are using tungsten in the bulbs means that is the reason. Very less in weight, understanding, but melting point is too much, so it can resist even very huge temperatures. So due to its very high melting point, the tungsten filament can be kept white hot without melting away. Understand? Without melting away. Understanding? That is the reason. Okay. So that is the reason why we are using this one. So also we are having other properties of tungsten which make it suitable for making these filaments of electric bulb. That is very light in weight. Understand? Very high flexibility it is having. Understand? That is one more reason. High flexibility. High flexibility and very understanding low rate of evaporation at very high temperatures also. Means breaking, or else it will converting into evaporate. Evaporate means another state. Gaseous state. Evaporation is rate is very low even at very high temperatures. So these are the reasons why we are using tungsten as a filament. So here you remember this tungsten filament of an electric bulb becomes white hot and glows to emit the light. Understanding when its temperature is about almost 2500 degrees Celsius only. So imagine that how much huge amount of heat energy. That is why this bulb, if you touch it outer surface after 1 minute also, you will feel it is hot, because that much fastly it is producing heat energy. Bulb, it will keep it immediately, it will produce a light. You know, imagine how much fastly the heat is producing. Understand? So that is the reason why we are using tungsten. These all are the reason. Understand? Like that, if it comes to here, if air is present inside this electric bulb, suppose, then what is going to happen? The extremely hot tungsten filament would burn up quickly in the oxygen of air. Understand? Because of chemical reaction will takes place. So that the electric bulb is filled with a chemically unreactive gas like argon or nitrogen. Why they are filling the argon or nitrogen in the inside the bulb beams? That is the reason. If you fill the normal air, then this tungsten, understand? Because they are chemically unreactive gases. So that is why if you fill the normal air, then this tungsten, when it is in extremely hot, it will react with the oxygen and it will gone. Understand? It will quickly will be over, because it will be burned quickly in the oxygen of air. So that way we have to fill this bulb inside, which there are chemically inactive gases like argon, nitrogen, or else a mixture of both. So these gases like argon and nitrogen, they do not react with the hot tungsten filament, and hence it will be prolong the life of the filament, understand, of the electric bulb. Okay. So like if you take the most of the electric power consumed by the filament of this electric bulb appears as heat. That is why due to which the bulb becomes very hot. Only the small amount of electric power is converting into light energy. So that light is also because of what? It is turning into white hot color. White hot color. That is only we are seeing as a light color. Understanding light, seeing as like a light. So filament type electric bulbs are not power efficient because of most of the heat energy. Understand, electrical energy is converting into heat energy only. Very less energy is only converting into light, so that they are not power efficient. That is why nowadays we are reducing the usage of this kind of bulbs. Understand? Efficient. So that is the reason why this tungsten light, understand, this kind of tungsten bulbs, they are replacing with the tube lights. Understand? Which they are more power efficient because they don't have any kind of filaments. That is the reason why we are shifting into now fluorescent lamps or tube lights. So this is the second application. Like that, if it comes to the next last application of this heating effect, the heating effect of electric current is utilized, understand, or else utilizing in electric fuse for protecting our household wiring and electrical appliances.
So suppose a few times you can see that short circuits will take place, and because of electricity, fire may catch by the houses and all used to take place. So suddenly when high voltage current will passes to our homes and all, that is very dangerous to us, because all the things will blast, everything will be gone, every electrical appliances will go into damage. So here we will use some kind of wire which is worked in the based upon this heating effect. Understand? That is only called as a fuse. So this fuse is a short length of a thin, understanding, a tin plated copper wire. Tin plated copper wire, a very thin tin plated copper wire. Copper wire, understanding, having a very low melting point. Low melting point in the sense of only it can resist till some temperature. Once the temperature reaches in the electric circuit is more than that, automatically it will be melting. So this thin fuse, which is having very higher resistance than the rest of the electrical wiring in a house. This is having a very more resistance compared to the other electrical appliances which were using in a electric circuit. So what is going to happen? So when the current in a household electric circuit rises too much due to some reason, some kind of problem in the electricity department or something, then the fuse wire gets heated too much immediately because of its high resistance. So it will start melts and breaks the circuit. So what is going to happen? Circuit will become open, so due to which the current stops flowing into our house. That is why everywhere where the energy meter is fixed to your home, down itself we are having some kind of fuse system. So there this kind of wire is used. This wire is what? A tin plated copper wire, remember, which is having a high resistance but low melting point. Okay, so this prevents the fire in house, or else due to overheating of wiring, and also prevents damages to various other kind of electrical appliances, understanding, in the house due to excessive current flowing through them. So if current is not flowing, because of it will break the circuit, it will melt and it will break, so that all the appliances will be, understanding, safe without any kind of damage. So these are the main very important applications of the heating effect of current. So let us in the next class, with this I am going to stop this today's class. In next class we'll discuss the what is electric fuse in more detail, understanding, in the topic on domestic electric circuits, understand, which is coming in the next chapter. In there we will study what is the fuse and how we need to connect in the domestic electric circuits and all. So with this I am going to stop this class, and even this chapter is also ended. This is the last concept which we are going to study in this chapter. So in next class we are going to study the next chapter called as magnetic effect of electric current. So in this chapter, next chapter is last concept, domestic electric circuits. We will study more importance about this fuse and all. Okay, so now I'm going to end this session. Thank you, have a nice day.